Okay, let's just look at the fourth example. Okay, so in the first example, what we have here is e to the power x, we have sine x. Okay, so apparently that sine x is appear first in the mnemonics. Okay, so the one that appear second will be the exponent. Okay, means that your sine will be your u. So you have u that is equal to sine x. And your dv, okay, the one appear first with your u, the one that appears second will be the dv, right, with the dv. So we have the dv that is the exponent, that is your exponent x, okay, together with the dx. Okay, so for the left hand side, we'll do the differentiation. So we differentiate it. So we have du here, and we have cos x here. Okay, when you differentiate, don't forget to write the dx for the right hand side. Okay, when you have du, you must have dx. Okay, so for the left hand side, okay, we're going to do the integration. So integrate this one. So we have v, and you integrate this one, you have dx. Okay, so let's just write the result out. Okay, so the first is you're supposed to have u multiplied with v. So your u is sine x. We have sine x, okay. And with the v here, that is the ex, okay. Then minus the integrations of v du. Okay, what is your v? So your v is ex, and your du is cos x dx. Okay, right. Okay, so let's just simplify it. Okay, so we simplify. So we have the ex sine x. Okay, for the right hand side we have minus integrate of ex cos x dx. It seems that the second item, actually you have to do the integration by part again, because you have the two functions here. Okay, you have functions, you have two product. So that is a product of ex and cosine. Okay, so let's just do the integration by part again. So again, you need the Liat. Okay, so let's just write out the Liat again. Okay, the Liat will help us to identify which one is the u and which one will be the which one will be the dv. Okay, so in here, so apparently we have the cos as cos referred to the t, so we have the u that is the cos x, and we have the exponent at the back. Okay, so the exponent, you go for the dv, so we have the exponent. So again, don't forget to write the dx together. Okay, now we repeat the same step again. For the left hand side, you're going to do the differentiation. So you have the du, and differentiate the cos. So we have the minus sine x. Okay, and don't forget, after you differentiate, write the dx. Okay, so for the right hand side, you're going to do the integration. So integrate, so you have the v, and this is actually dx. Alright, okay. So before we apply the formula of the integration by part, let's just write out the first item first. So this is the first item, okay, and minus. Okay, let's focus on whatever that we have here. Okay, so we have this one, right? Okay, so now this is the time we're going to apply our integration by part again. Okay, so let me write it in a bracket. Okay, so you have a product of u multiplied with v. So what is your u? Your u is cos x. And what is your v? Your v is ex, right? So when we multiply, we will have ex cos x, right? Okay, then minus with the integrations of v. Okay, what is your v? Well, your v is ex. Your v is ex. And your du, where's your du? Your du is this one. So we have minus sine x dx. Okay, now close the bracket, right? Okay, so basically I use different towel, and you can see that it's important to put a bracket, okay, because the integration by part, okay, you have a minus in front of it, it belongs to the whole thing, right? Okay, so now let's just simplify before we go further. Okay, so let's simplify on this one. So we have ex sine x, and we have minus ex cos x. Okay, what happens if we simplify this? Okay, you have a minus in front of the red bracket. Okay, so we have minus, and you have a minus here, and you have another minus here, so you have 3 minus in total, so it will give you a minus. So minus e x sine x dx, right? Okay, why we say that? Because you see we have the minus, we have the minus, and you have the minus. You multiply the minus 3 times, so you have the minus. Okay, now let's just look at this one. Okay, what happened if we want to further? Okay, it seems that we are trapped in something. Okay, because it seems that we have to do the integration by part for the third time. But before you do the integration by part for the third time, let's just see what that we have in the questions. Okay, so we supposed to integrate this one for the third time, okay? But if you look at here, look at this one before you do the integrations, it's basically exactly same as what we have in here, exactly same as what we have in the questions. It means that we are actually in a loop, okay? In a loop that you repeat to the same item. You repeat to the initial. Okay, so what can you do with these type of questions? Or what you have to do is, first of all, copy the questions. So you have the questions. So question is the integrations of ex sine x dx. This is the questions, right? This is the questions. And okay, write the result. Where's our result? This is our result, right? Okay, so write out our results. So you have ex sine x minus ex cos x minus ex sine x dx. Right, okay. So if we look at here, okay, so what I focus is actually the question, and the results that we have not completed, right? So I just put here. This is the questions, and this is the result, right? Okay, what we can do is, okay, so if you observe, because we have the same item, at the left and at the right. So what you can do is try to group them. Okay, how to group them? So you want to make this disappear on the right hand side. What you can do is actually you add the same item to the both sides. So you just add, right? You want to make this one disappear. You want to make this one disappear. So what you have to do is, because it's in terms of minus, you use a plus. So it will disappear, okay? So let me write it, okay? So you have ex sine x at the left hand side. So now what you have to do is you write a plus to the left hand side. So you have ex sine x dx. Okay, and for the right hand side, we have ex sine x minus ex cos x. Okay, we have minus ex sine x. Remember, just now we add a plus, we add the integration of ex sine x to the left hand side, and we have to add it to the right hand side also. So when you add both sides with the same item, we do not change the question. We still have the same question, but why we want to do that? Why we want to add something like that? Okay. Remember, just now I said that you have to cancel out. You want to cancel out the minus item that is on the left, on the right hand side, on this one. So when you plus the another item that is actually the same, so you have minus that item plus that item, so you have a 0. So this one will give you a 0. So this whole thing will end up as a 0, right? Alright, okay, so now, okay, let's just simplify it. Okay, so for the left hand side, if you simplify it, because you have the item, okay, that is appear twice, so they plus, so you have to add them together. So you just imagine you have one orange and you have another orange here, so you plus the two orange together. Okay, so basically you total out, you have two orange, right? Okay, this is one orange, this is another orange, so you plus them, so you have two orange. So what is your orange? Your orange is actually EX sine X. So what happened to the right hand side? The right hand side you have the EX sine X minus EX cos X. Okay, so what is the thing that I did here? Okay, what is the thing that I did in the previous step? The previous step is I add, let me use another color. I add EX sine X dx to both sides. Okay, so let me use another color. So it's to both sides. Okay, so to both sides to this line. Okay, so now, okay, back to this line. Okay, so back to this line. So what we are interested in is actually just the integration. We don't want the 2 in front of the integration. What we can do is you have to multiply. You have to multiply both sides with 1 over 2. Okay, so you multiply 1 over 2 to both sides. Both sided. Okay, so if you multiply 1 over 2 to this side, to the left hand side, what happens? So you have the 2. So you have the 2 here. Okay, you multiply with 1 over 2. So what happens? So you have 1. 1 over 2 multiplied with 2, you have 1. So then the result is actually just EX sine X dx. And how about the right hand side? The right hand side, we have to do the same thing, because we say that we want to multiply 1 over 2 to the both sides. So if you multiply with 1 over 2 to the right hand side, you will have 1 over 2 here. Okay, then we have a plus. Okay, so this is the result, and don't forget to write a plus C. Okay, so this is the result for the example number 4. Okay. Let's just look at the example 5. Okay, what we have here is we have the tangent inverse, and that tangent inverse is actually referred to the I. Okay, so means that you have your u as is actually as the tangent inverse x. So we have done with the u, and we're going to look for the dv. Okay, which one is our dv? Our dv is actually referred to dx. Okay, so we refer to the algebra. Okay, so that is your dv is actually equal to x. So we have found the first 2 important things that you need to know in order to use the formula. So now we're going to do the differentiation for the left hand side. Okay, so if we differentiate the left hand side, So tangent inverse is basically would give you of the derivative of this one, 1 over 1 plus x squared. Okay, and don't forget to write the dx. Okay, and for the right hand side, we're going to have the integration. So you integrate, so you will have v equal to x. Okay, so now let's just look at the formula. The formula says that you will have the product of u and v. They're going to multiply u and v. So you have tangent inverse and multiply with the v. So you will have the x multiply with tangent inverse x. Okay, so then you have the minus. You have the minus there. We have minus integrations of v. Okay, our v here, that is the x again. So we have the x. Okay, and then we have the du. The du, that is this one. So we have 1 plus x squared dx. So so how we're going to solve this one? Okay, so before we solve this one, let's just simplify it first. So then we will have this. Okay, what you see here is you can solve it by using one formula. Okay, so because you observe that actually we can use one formula that is this one, which is you have the integrations of the function f divided by function f. So in terms of x, right? Okay, so it's equal to the ln, so ln f, it's supposed to be ln f, ln f, okay, plus c. Okay, so which is actually, we look at this one, this is basically your function f, right? Okay, if I want to get my f prime, okay, so this is my f is 1 plus x squared. If I want to use this formula, so what's supposed to be my f prime? Okay, your f prime is supposed to be this 2x, but what you have here is you only have x at the top. So what we can do, just say we can use this formula. So the thing that you have to do is you have to do a bit of manipulation. So okay, let me copy the first item. Okay, so the things that you need to manipulate is, okay, we still have this one, as I said just now, we need the 2 at the top, okay, because we want to have the function f prime. You have the f, and we need the f prime at the top. So what we can do is we add a number. We add a number that is 2. Okay, if you add the number of 2, you will have f prime on top. But unfortunately, we have changed the questions. But we do not want to change the question. What supposed to be going to do is we multiply with another number that is 1 or 2. When you have 1 or 2 and 2, okay, basically they give you 1. So we do not change the question. When we do not change the question, okay, and we are able to use this formula, okay, and okay, let's just look at the next time. We have the x tangent inverse, and then you have 1 or 2 at the front. And what you can see here is actually I have the form that I want, that is this one. It says that, okay, you have the f prime over f. When you integrate it, you will have ln f. Okay, so you will have the answer of ln f. This is ln f. What is your f? Your f is actually 1 plus x squared, right? Okay, so for this question, we do not want to write the plus c because we have the value. And the integral. Okay, so this is the finite integration. Okay, so we have a value, so just remember we have to continue the step. Okay, so we have to substitute the value of 1 0 here. Okay, let's do the substitution and see what happened. Okay, if we substitute here, so you have, this is actually 1, and you have the tangent you have the 1 here, and you have the tangent inverse 1 minus 1 over 2, You have the ln. We have the ln, and 1 square plus 1 is actually give you 2, right? Okay, so that is you substitute x as 1 into the equation. Okay, and we have to substitute x equal to 0 into the equation, so we have 0, and we have the tangent inverse. Okay, we have the 0 here, and then we have the 1 over 2, and again you have the x squared. Okay, 0. Okay, so 0 plus 1 is 1, so we have ln 1. Okay, and if we look at this one, so what we have here is basically this one is actually end with 0, because 0 multiplied with anything you have 0, and ln 1 is basically 0, so we have 0 here. Okay, so then, okay, let's just look at the tangent inverse. Okay, so tangent inverse 1 is actually give you pi over 4, and then this one we have the answer of this one. Okay, so that's the answer for example 5, right? Okay, let's look at here. Okay, so you have the tangent inverse, and you have the dx. Okay, so dx is go for your dv, right? Okay, so we have the tangent inverse, that is your I first, so we have the u as the tangent inverse, and then we will have the dv, so dv, that is the dx, the dx here. Okay, so now I'm going to differentiate the left hand side. So differentiate the left hand side, you have du, and it's 1 over 1 plus x squared. Okay, for the right hand side, so we have the integration. So if you integration, so you have this one is the v, and this is actually x. Okay, so refer to this formula. The answer of this one is supposed to be the product of these two things. So we have the x and tangent inverse, and we have the minus and minus b. Our v is x. Okay, and then you have the du. Your du is actually 1 plus x squared, 1 over 1 plus x squared. Okay, let's simplify it. Okay, okay, so in order to solve these questions, you can use the substitution to solve. Okay, so if we want to use the substitution to solve, okay, so we're going to choose to write this one as the a. Okay, then we don't use the u anymore because we already have the u at the top. Okay, so in order to avoid confuse in when you're using the formula, why don't we use another variable? Okay, so we're going to do the substitutions. Okay, so it's a substitution. So we're going to do the substitutions, and we're going to substitute a as 1 plus x squared. So it means that at bottom we have the a. Okay, so when you have this one, okay, we want to integrate. Okay, so what you have to do is, okay, try to make this integration become simple. So we have to differentiate this. Okay, so if you differentiate this one, you have dA, and it's 2x dx. Okay, so we can observe at the top here is you have this one, that is x and dx. Okay, so you have x dx here. So we manipulate this here, we manipulate here, so we have the dA over 2, so then we have x dx here. Okay, so what happened is, why we want to do that, because it's later we're going to do substitution here. So we have the tangent inverse x is for the first item. Okay, for the second item, there's a second item that you can see that you have the x dx. The x dx is this one. So what is the x dx? The x dx is basically the a over 2. All right, so now let me write it back. Okay, so in here at the bottom we have the a, and x axis actually give you dA over 2. So you have the dA over 2 here, right? So this one is basically what? This is actually, we can write it back. We just said, okay, so this is actually 1 over 2, 1 over a dA, right? Okay, because you have the over 2, you drag it out. Okay, so we have this, okay, and then we have something that is very simple for you to do the integrations, and we have the 1 over 2, and this is actually ln a. Okay, so but if you refer to questions, our question is not a, but our question is x. Okay, our question is in terms of x, right? In terms of x, then we have an a here. So you have to change it back. So let's change it back. So if you change it back, so you have the x tangent inverse x is equal, okay, minus 1 over 2 ln a. So your a is 1 plus x squared. So 1 plus x squared that is coming from here, right? So we have here 1 plus x squared. Okay, don't write the plus c because we have the value at the integration. This is the finite integration, so we have the value of 1, 0 here. Okay, so we're going to do the substitution now. Okay, we'll sub the first one, the first bracket. Okay, we'll sub all the x as 1. And I'm going to see the x squared here, so you sub 1, so you have 1 squared plus 1, so that is give you 2. Okay, and then we're going to minus. Okay, when you substitute the x as 0 into here, so you have the 0 tangent inverse 0 minus 1 over 2 ln 0 square is 0 plus 1 is 1. Okay, and then out, okay, we will have these two items as 0, right? Okay, so the things that remains here is you have the answer as pi over 4, and this is 1 over 2 ln 2. That is the answer. Okay, let's just look at the example 6. Okay, so what we have here is the inverse of the function sine. So you have the u as the sine inverse, and you will have the dx, that is your algebra. Okay, so that is your dv, right? So now you will have your dv as your dx. All right, okay, so okay, let's just continue the step. Okay, so now we're going to do is you're going to differentiate the right hand side. So you differentiate the right hand side, you have the du, and this is actually 1 over, okay, if you want to differentiate this side, so it's better for you to change it to something that is more easy for you to do the differentiations. So this one, we just going to do the substitution. So you sub this one as the I. So let's say we have I as 3x. Okay, so when you do the A as 3x, okay, let's just look at example 6. Okay, so now we have the tangent inverse, that is your u here. So you have your u is actually sine inverse, so you have the u as sine inverse. and then you have the dv is your algebra. Okay, so we have the dv here, so your dv is your algebra, that is dx here. For the right hand side, you have no problem to integrate. Suppose you will have the v equal to x. How about right hand side? Right hand side, if you want to differentiate, so it's better for you to substitute this one as a. Okay, so we're going to do substitutions. Okay, you're going to sub the a as 3x. Okay, when you have sub the a as 3x, what happens is we will have u is equal to sine inverse a. Now, it is more easy to differentiate this one. So if you differentiate this one, we have a formula of this. This is actually 1 minus a squared dA. And now you have to subdivide. Okay, what is actually your a? Okay, so your a is actually 3x. Your a is actually 3x. Okay, so what is a squared? So your a squared is 9x squared. And we have dA here. So what is our dA? So you have to differentiate from here. So you have your dA, and it's 3 dx. Okay, so this one is 3 dx. So this is our du. Okay, so let's just substitute. Okay, whatever that we have go into this formula. Okay, so now first of all, you will have the u multiplied with v. So u multiplied with v, so this is your u, and this is your v. You multiplied it, you will have the x sine inverse 3x. Okay, then followed by minus v. The v here is x. Okay, and then du. What is your du? Your du is, okay, your du is this one. Okay, so we have the bracket 3 dx over 1 minus 9x squared. Okay, let's simplify it. Okay, so if you look at this one, okay, the same thing. If you want to integrate it, you have to manipulate it, okay, and you have to use the technique of the substitution one more time. Okay, so now let me substitute. Let's say I'm going to substitute whatever down here with another variable. Okay, so we're going to do the substitution. So we're going to sub let's say v. We already use the u and v. We have to use the a, so use b. Okay, so you have the b, so we have the b as 1 minus 9x squared. So if you differentiate this one, you have db equals to minus 18x dx. Okay, so now you can make it of whatever that you have here. Okay, do the substitutions as it says that this is your b. Okay, and then what happened to our x dx? Okay, our x dx is here. So we have our x dx is, it is x dx. So what is our x dx? Our x dx is actually db over minus 18. Okay, so now we can do the substitution for the next slide. So for the next slide, okay, so we have, okay, for the first item, we just write it back. So we have x sine inverse 3x, okay, and then minus, okay, we have the 3 here, we still have the 3, okay, over with, okay, then we have the b here, we have the b, and how about the x dx? Okay, x dx is, here, x dx is db over minus 8, db over minus 18, okay. So let's simplify it, then you can go to integration. Okay, so we simplify it, so we have the x sine inverse 3x. Okay, this actually gives us 3 over 18. 3 over 18 is 1 over 6. And then set b. The b here is actually over b, right? So you have minus 1 over 2 db. Now you have something that is very easy for you to do the integration. So now, okay, if you integrate this one, so basically plus 1, so you have b 1 over 2 over 1 over 2. We have plus c here. Let's go down, okay. And then, okay, then we have the x sine inverse 3x. Okay, this is actually give us 1 over 3. Okay, I'll just focus on the number, only. Okay, so we have 1 over 3 here. So 1 over 3 for the number. Okay, so then we have b 1 over 2, b power 1 over 2. But remember, our question is not in terms of the b. You should not stop your answer at this part, because your question is in terms of x, right? So all of your answers are supposed to be in terms of x. Okay, where is the b? Okay, we have the b here, so we have to change this b back to x. Okay, so where is the things that you can change? That is here. Just now we have substitute the b as 1 minus 9x squared, right? So substitute back, okay? So then you will have the b is 1 minus 9x squared. Okay, we have the 1 over 2, don't forget that 1 over 2, and plus c. Okay, so this is the answer for this example. Now, our question says, is it possible for us to solve this integration by using the formula of the integrations of f prime over f dx?